Hey guys, welcome to the next lecture on equations that are really just quadratics pretending to be something else. Today we're going to talk about the quadratic form equations. These are essentially just quadratics where we have to make one substitution and it looks just like a regular quadratic. So something is in quadratic form if it looks like some function f of x squared plus, and there can be coefficients out in front, plus b f of x plus c equals 0. So it's really just some equation. We see an equation involving x that's just repeated. So in the sense, I think it makes sense in this example below, where in this example our f of x is equal to the square root of x. And we see that as noting that x equals the square root of x squared. So our equation is literally asking us to solve the square root of x squared plus 2 square root of x minus 3 equals 0. We do a little trick that we call U sub. Actually, I had a professor who got mad at us whenever we called something a trick. He would say it's a standard technique. And I guess in this case, it kind of is a standard technique. You set u equal to the square root of x. And then we just take u and plug that into our equation wherever we see a square root of x. So that gives us u squared plus 2u minus 3 equals 0. And now we're well on our way to finding a solution because we just have a quadratic and we know how to solve that. This one's a pretty easy one to find using the diamond method. So we just want to find a and b, where a plus b is 2 and a times b is -3. And hopefully it's pretty easy to see that that means that a will be 3 and b will be -1. And therefore we can factor this equation as u minus 3, sorry, u plus 3 and u minus 1 equals 0. So that tells us that our solutions are u equals -3 and u equals 1. All right, so we have our solution now in terms of u, but we really want a solution in terms of x. So then we resubstitute x back in. So that tells us that we need the square root of x to be -1. Or we need the square root of x to be, oh, sorry, I wrote that backwards. We need the square root of x to be 1, or we need the square root of x to be -3. We have our convention that the square root is not negative, therefore we know we can't have a solution to the bottom equation, so we have to have that x equals 1 is our final solution. And we can also see just by plugging that in that when we plug x back in, we get 1 plus 2 times the square root of 1 minus 3 equals 3 minus 3, which is 0, which is exactly what we wanted. Therefore, we're good. And then I have a second example as well. So maybe instead of me making the substitution right away, you guys think of what the substitution can be. So just pause the video, think about what the substitution is going to be in this equation. And hopefully everyone was able to figure out that we should have u, set u equal to x squared. Since x to the fourth is just x squared squared. Therefore, when we make the substitution, we have u squared minus 5u plus 12 equals 0. Oh, I'm sorry, I didn't write an equals 0 at the top. That's what we should be solving for. And we're just going to attack this with the quadratic formula. So we'll find that u equals negative b plus or minus square root of b squared minus 4 times negative b all over 2a. And that then gives us 5 plus or minus the square root of negative 23 over 2. So at this point, we're left with two options. I think the book thinks you guys don't know complex numbers. I'm not going to assume you know complex numbers yet. So if you've heard of complex numbers, then you know that we can make sense of the square root of negative 23. If you haven't, that's perfectly fine. And that's what we're going to say, that the square root of negative 23 doesn't make any sense. Therefore, there's no real solutions. And just to clarify why we have to say no real solutions, the emphasis is on real because a real number is a number that does not involve a square root of a negative number. So there are these things called complex numbers, which are a bit more general than just the real numbers we're used to, that allow us to make sense of what the square root of negative 23 is. In that case, it would have a solution. But at the moment, we're saying there are no solutions. All right. Yeah, so that's it for the quadratic form. Really, the method is to just find out how to substitute that u in. And maybe I should add an addendum. It only works when it follows that f of x squared pattern. For instance, we can't do quadratic form on something that looks like x cubed plus x plus 1. Because x cubed is not, if we took the square root of x cubed, we would get x to the 3/2 and not x. Also, x to the 4th plus x squared plus, let's say 2x, is also not quadratic form for that same reason, where we need the last term to actually be a constant term and not a value in x. And this, I think the last thing is, this technique actually comes up a fair amount. I think I went most of my college career without ever seeing it until I was taking an advanced applied math class. in my senior year, and this method came up all the time where in applied math you end up with like pretty gnarly equations that you have to deal with, and just being able to make this substitution with you to turn it into something that you can easily solve really just like changes like how you can approach the problem, and really makes it a lot more manageable. All right. Well, this is it. Farewell.